Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we're going to present for the lab digital signal processing, lab 1, with me, saya Ahmad AMSYAR bin SYED, and with my partner Ahmad Firdaus bin Muhammad RASDI. Okay, for the first lab 1, question number 1. Okay, first we need to rewrite this coding to MATLAB, like over here. Okay, then the question, what is the sampling rate used in generating the signal? Okay, so we use the 1 over fs, which is 1 over 20 hertz, and then we get 50 ms, and then we convert it to second, we got 0.05 second. Okay, question B, change the frequency of 70 hertz. What is the signal produced? Okay, I have changed the frequency at here, and then I got the result. Okay, so based on our observation, we got the graph slightly different from other frequency, which is here is 70 hertz, here is 4 hertz, 3 hertz, and 7 hertz. Okay, and then where the question? Okay, so we can conclude that they are aliasing between the frequencies, such as 5 hertz with 50 hertz, because the difference between these two are quite big, so we can see the difference clearly. Okay, C is which of the signal generated will not comply with nuclear sampling theorem. Okay, by referring nuclear sampling theorem formula, which f1 equal to fm, signal frequency 13 Hz, 15 Hz, 16 Hz, and 17 Hz is not compliant. Okay. And for question D, what is the maximum frequency of F1 for the sinusoidal signal X1 that we can adopt in lab 1? This lab. Okay. Okay. So, maximum frequency of F1 for the sinusoidal signal X1 is 10 Hz. Okay, if we exceed the maximum value, it will cause the signal we generate aliasing with other signal. For example, 5 Hz and 50 Hz we generated earlier. Okay, and then for the question number 3, complete the code given below to generate common signal used in the SPE as in figure 1. Okay, so we need to use the coding. We need to complete lah. And then to generate this for signal. Okay, and then here the coding. Wait. Okay. So we can see that here is the signal. Wait. Rectangular signal. Ini impulse signal. Signal and exponential signal. Okay, so we got 4 subplot here, and then we use the sampling 20. Okay, okay, I'm going to run it. Okay, so we got a graph like this. Okay, so because we use 20 sampling, and then we got another 20 sampling there. Alright. Okay, so here the rectangular signal, unit impulse signal, signal, and exponential signal. Okay, and then okay, present the complete code output signal. Okay, so here are the output signal. Okay, that I got. Okay, next is number 2. I'm going to pass it to Ahmad Firdaus to explain it.
Okay, next the part 2, which is a basic signal operation in time domain. The first one we are going to require to write the coding that has been given and put the our own code. Okay, As you can see on the MATLAB, this is our code. For the frequency of the signal in Hertz, I just put the command F2A for 300 Hertz, and for the sampling is 5 times 2A, which is 300, 5 times 300, same as the X2B for the 500 Hertz. Okay, so basically the signal for X2A is 300 Hertz, and for the X2B is 500 Hertz. And then we run. So this is the output that we got. The left is the 300 Hertz, and on the right is the 500 Hertz. As you can see, when the frequency is increased, the distance between two samples is tight. Okay. Okay, next is the next we are going to require to do the to include the sound, which is I put the signal 1 dot wave as the sound 1 and the signal 2 dot wave for the sound number 2. So this is our complete coding. Okay, we're gonna run, save, run. Do you want more? Why? Okay. That is the when we put the command Y, the first sound will come and then go into the second sound. Okay, next I'm gonna another one, which is put N. Okay, for the second is for N is the second sound that will come first and then the first sound. Okay, next is the question 3A. We are going to require to use the function convolution to generate the convolution between Sn and Hn. Save and run. Okay, this is the output that we get. The first one is the rectangular signal. The second one is the sine signal, and the third one is the convolution between Sn and Hn. The rectangular signal, we have the 20 sample, same as the sine signal, and the convolution all has the 20 sample. Okay, next for the question 3C, which is we're going to do same as the question 3A, but the first one is the unit impulse signal. So this is the output that we got. The sampling is also 20, and the 25 for the sine signal, and the third one is the convolution between Sn and Hn. Okay, next the last one. Okay, last one. We're gonna test the sound that we download on our own. Which the first one is rain and the second one is thunder. Okay, save and run.
Wait, seem like got error there. Oh, yeah, audio read. Need to change it to audio read. Record.
Okay, to audio read. Okay, we're gonna run. Okay. So basically, the first sound is the rain sound, and then the second sound is the thunder. Okay, that's all for the our lab one assessment. That's all. Thank you.
Okay, thank you very much.